All right, guys. First off, any questions about the homework?
Can we have more like it?
Was it really easy?
I like the numbers, yeah, or even.
All right, cool. I'm going to be a little more zoomed out today because my camera's acting weird and it's like flopping and I don't have any way of tightening it, so everyone can still see it fine, right?
You need a screwdriver?
It doesn't even have screws.
Oh, okay.
It's the dumbest thing. So I'm going to have to like figure out how to tighten it, but thank you. Yeah, I'll figure it out. Okay, so no questions about the homework. Let me go over my post in the group from yesterday. It was pretty late last night, just in case anybody didn't see it. So I made some announcements. So I'm not going to be here Wednesday. So for anybody who didn't see the post, we will not have lecture Wednesday. I guess I don't even need to go over this. I can just go straight to the webpage. I made the changes. So Wednesday is no lecture. I'm not going to be here. I'm not going to post anything. There's no homework due, obviously. Homework 9, the one that's due today, was the last one before the midterm. So the midterm will cover pretty much everything from homework 1 through homework 9 and all the way up through the quiz that we're going to take today, which is just another homework problem basically. So if you had no problem with the homework, you shouldn't have any problem with the quiz. On Monday of next week, I'll do a review for the midterm where I'm basically just going to answer questions and work problems. I think that the best way for that to be productive for everybody and probably not going to work out this way because most people just aren't going to do anything over the weekend. But if you want it to be productive over the weekend, go over the homeworks and quizzes that you have that I've handed back, and just see which problems cause problems for you, and bring them to class so that we can talk about them, because I'm not going to remember what everybody was struggling with. So just if there's something that you want to go over, and I'll do like a brief overview of like what each question will target and what topics you should hammer down on. Something I maybe haven't mentioned, but I definitely want to mention, is that when you guys study for classes like this and any engineering class moving forward, the only way that you can really learn the material well is to solve problems. Like, you cannot watch my videos. I mean, my videos are great, I think. But if you watch the video only, that's just not going to benefit you that much. You have to go and do it by hand, because if you don't, I'm making it look easy because I know what to do, and you're following. But then when you get a problem in front of you, right, you might blank out because you haven't physically done it. Even if it made perfect sense to you how I did it, you have to build the problem-solving skill. I know what the first step is. Even if you know what the second, third, fourth, fifth steps are because you watched me do them, if you don't know the first step, you're going to be stuck there staring at it, right? And this midterm, when I give the midterm, you have 6 problems basically, and you're going to have an hour and 15 minutes. So that's roughly, if I were to say that was roughly 6 quizzes, it's kind of like shortening all the quizzes to less than 15 minutes, which 15 minutes is plenty of time to do the quizzes in most cases. But just so you know, it's basically the time of 5 quizzes, but it's 6 quiz-like problems. So you're going to have to be moving a little bit quicker than you would if you're on the quizzes, right? So just like I said, when you study, make sure you're solving problems like by hand, doing them fully, check them in Spice, see if they're right. Those are good habits to get into, because if you're in the habit of reading material and watching videos, but you never actually solve problems by hand, you just can't build the skill, and it's going to feel really difficult, and you're probably getting frustrated, like, why in the world is it so easy when I'm doing the homework, but then when I take the quizzes it's so hard? There's a lot of people doing really well on the homework, very obviously like following along with everything that I'm saying in class, but then the quizzes are just rough. And it's literally just because you probably haven't done enough practice problems to where you feel comfortable just tackling a problem when you see it. And that's where you need to get to if you want to do well on the midterm. I'm not throwing any curveballs at you guys. I'm not doing anything crazy. It's going to be very similar to quizzes and homeworks you've seen before. But if you're not able to move through problems similar to what we've seen before quickly, then it's going to be difficult. Okay? Yeah.
Do you have any source for practice problems other than the quizzes and homeworks that we've been assigned?
Yeah. So I don't know. This is where this Baker's old courses is a very good resource. So, like, just for example, if I go to fall 2021 and go to his homeworks are going to look similar to mine. They're not the same, but like, here's just a bunch of circuits to solve. There's Steven and Norton. I'm basically going in the same order he did. So if you want to go like, oh, I had a problem on homework 7, look between like homework 6 and 8 of his, and there will be probably something similar. So like homework 8, right? He's got some 3-loop using both superposition and mesh, right? That's basically what we just had. But these are very different from the circuits I just gave you guys, but very similar at the same time, right? So all of his classes, and I think if you go to his lectures, he has his quizzes too. So if you want to solve some of his quizzes, right, determine Vx and the current through R3, right? They're very similar to my problems, but they're all going to be different from all the years because he never like duplicates anything. It'll just be close. So this little section of my webpage on the front right here at the very bottom, right, all of these are just filled with homeworks and quizzes that he has for you to, if you want to solve them. He might even have his midterm in there somewhere. Let me look at like fall 2021 lecture notes. Yeah, so his midterm is right here. So if you wanted to like practice by solving his midterm.
So would you say that would be the closest, like best reference you can use for this midterm?
Yeah, I would. I mean, obviously I didn't copy it,
Yeah.
but I did. It's 6 problems. Like I based my exam format off of his. So basically, his was probably like six problems similar to his six of his quizzes, and mine is going to be similar to 6 of my quizzes, right? So yeah, this is just a wealth of problems if you want to solve, however many you feel, until your heart's content.
Do you think there's going to be any triple loop problems on the exam?
Do I think?
Do you plan for there to be?
Honestly, I don't remember. I think I did put one, but it's not anything crazy. It's very similar to your homework.
All right.
I think.
I'll just do the homework.
Yeah, and
Confirmation on that one?
what's that?
So you want to give the confirmation?
I don't remember, and I'm not going to pull it up. So I'll have to check. But when we go over the the review, when we do the review next class, I can solve problems like that, similar problems. I can solve his 3-loop ones if you want to see more.
Oh, I remember originally you said you wanted to have the midterm on that Monday, so it is going to be moved back though to that Wednesday, right?
Yeah. So
And it's because you're going to be out of town.
Yeah. So I basically I'm going to be leaving Wednesday morning, so I'm not going to be here to do any sort of review. And like I said, I don't think a lot of people were like interested in doing a weekend review. So I just figured it's better to push it back to Wednesday, and we'll do the review in class on Monday. And then if there's more review needed, maybe we could do something Tuesday, the day before, if people are open to it. I don't know. We'll see how the review session goes, and then I'll ask at the end. Because obviously there's no more quizzes before, after today at least, there's no more quizzes before the midterm. There's no more homeworks before the midterm. So now it's just everything we've learned up to this point. There's no new topics either. I'm not going over anything new today. I was just going to review, source transformation, or sorry, not source transformation, but dependent sources. And I don't think anyone had problems with power or dependent sources, but I'll go over a couple examples, I guess. Actually, so no one had any problems with the homework at all? Like none of those 4 problems? Everyone figured it out?
They're pretty cool.
All right, well, my plan today was to do more of those, but if nobody needs help with those, then, I have no problem starting review today for the midterm if everyone's cool with that. Is everybody cool with that?
Yeah.
You have a question, or you're cool with that?
I think it's good. Yeah. Well,
All right. All right, then, yeah, we can start reviewing today, and we can keep reviewing Wednesday. Were there any topics in general that anybody thinks that, it still bothers you and you want me to go over an example? Yeah. Seven and Norton. All right, so let me just list these. I feel like I'm going to get a list of every topic in the class.
The whole class. Well, since we got 2 days, why don't we
We might as well go over everything, right?
start and stop?
All right, well, let me just list the things that you should know, and then I'll put little X's next to what people think are the hardest things. And if I get an X next to everything, then I'm going to be annoyed. Hold on, let me get water. All right. So, I guess first things we covered in this class was like Ohm's law. Stop. All right, so I'm just going to go in order of the things that you should definitely know. Okay, when I say you should know them, I don't just mean, V equals IR. Like, you should know how to apply this, right? Everyone knows that V equals IR, but that doesn't mean anything if you don't know how to apply it. So when I say these are the things that you need to study, don't put V equals IR in your brain and then be like, I don't need to study Ohm's law. Make sure you know, where to apply it. And that includes power, right? Which we just went over last time. So you got P equals IV and all those other variations of the equation for power. After Ohm's law, what do we cover? Series and parallel equivalence. Make sure you guys understand those. Okay, so after that, I think we went over KVL and KCL. I know that some people still struggle with that stuff. That's totally okay. And then I guess we went into probably just nodal analysis. I never called it that, but that's just basically when you solve the circuit by just examining the nodes and finding the voltages. Not using superposition, mesh, KVL, KCL. It's just like I'm going to eyeball this circuit and I can kind of, figure things out based on the equations that we know from Ohm's law. And then I guess we did voltage and current dividers, right? Then probably superposition and mesh. Any? Analysis. Then I probably did Thevenin and Norton. Am I missing anything that anyone can think of? Thevenin and Norton, and then source transformation. Okay, and then the most recent stuff was power dissipation. And dependent sources. So that's pretty much the first half of the class. Can anyone think of anything I'm missing? All right, cool. So what I'm going to do is I'm going to go down this list and I'm going to write the number of hands raised that think a particular topic is difficult or needs attention. Okay?
I have a question. So none of the superposition or mesh analysis is going to need a combination of the both, like in the one home, also.
I don't know. I don't know. Maybe it might.
Yeah, homework you didn't have to use both to solve it once. You just needed to use one method to solve it. So
Yeah, but the one I figured out is that it had to use part of mesh analysis in superposition.
Yeah, when you do superposition and you remove one of the sources, you could potentially still have to use mesh. You don't have to, but you could use mesh.
yeah.
See, the thing is, when you only have one source in a circuit, which is what you're doing when you have superposition, right? You're removing all but one source and checking. You never have to use mesh if you only have one source, right? You can always reduce the resistors into an equivalent. But if you were to get another problem like that, where you can do, you have to do superposition with 3 loops, and say you get it down to 2 loops, and then you want to do mesh, that's fine, right? When I say solve this using superposition, the overarching principle in superposition is remove a source, solve the circuit, and then remove the other source, solve the circuit, and then add them. So if for whatever reason when you remove a source, you get a circuit that you want to solve using mesh, that's fine. But you're still using superposition, right? So if I say solve it using superposition and you don't remove sources and do the superposition, then that's not good. A big thing with this exam is going to be following instructions. I made the instructions very clear. I put some hints in the instructions. So please read the instructions. I can't tell you guys how important it is to read instructions.
Is there any extra credit questions? Like, what is the genre of music that I play every morning or something like that?
Well,
Or what is your favorite color?
what's my favorite color?
Teal.
Oh yeah, look, two people got it. I think I put it on like one of the videos, right? That wasn't a lecture. Yeah, but then I decided it wouldn't be very fair.
I mean, you can put those as like extra credit questions. That'd be funny. My favorite color is teal. Okay, that's
Guys, I don't think you're going to need extra credit. This exam's easy. It's going to be easy. Yeah, I've seen your quiz grades. I have seen your quiz grades. All right. How many people want me to review Ohm's law? Okay, so that's 0. So that's good. If you do, it's okay. Don't be ashamed. Series and parallel stuff. Nothing. All right, good. KVL, KCL. 1, 2, 3, 4, 5, 6, 7. Okay, well, I'm just going to put 10 plus, which is good. Nodal analysis. Okay, 5, 6. Voltage and current dividers. 1, 2, 3, 4, 5. Superposition and mesh. Lots. Okay, lots. I don't know how to write a number for that.
Now it looks like your 10 plus says a lot.
Enough, right? Enough, people. Thevenin and Norton. Yeah, pretty much everybody. Source transformation. A couple people. Maybe just put 5. Power. Did anybody have problems with power? No? Okay, good. And then dependent sources was easy for everybody. Maybe go over a couple.
I have an esoteric question about it.
Yeah, if people have questions about them, we'll go over them. Maybe we should go over those first since the quiz is on that today. Let me just star everything that I'm going to cover. All right, well, you guys should study all these things, but I'm going to review the things that I've starred. So, starting with dependent sources, and then we'll go from KVL, KCL back to more recent stuff. Okay, so let's just answer people's questions about dependent sources. What was your whatever word you used question?
When you have a current dependent voltage source, I noticed that we were multiplying by like 2,000 in our homework. I think on 2C.
So when you have a current dependent voltage source?
Yeah.
So this one.
2C.
This is current dependent voltage, right? This one? Yeah, okay.
So we're multiplying by 2,000.
That's right.
But it's not 2,000 ohms, so we're outputting still in amps, because that's just a scalar, right?
You're outputting in volts.
Okay.
Because this is a voltage source.
Okay. I was just wondering, like, unit-wise, since we're taking in amps, which is voltage over resistance, and then we're multiplying just by a scalar, we're still just outputting by volts.
Well, you're multiplying by a scalar, but that scalar has units of volts because it's a voltage source.
Okay.
So basically, these different amplifiers and things in real life, they're called transimpedance amplifiers.
Okay.
And it's because, well, I mean, I'm not going to explain why it's called that, but basically, you're taking current in somewhere in the circuit and you're outputting voltage somewhere else in the circuit.
Right.
So there's no like real conversion of the current to a voltage or the voltage to a current. It's just that circuit behaves such that if I put, let's say, as a gain of 5K, if I put 1 milliamp here, and then somewhere else in the circuit, the voltage is going to be 5 volts.
Okay. So I guess my question then is, this piece, this component, sorry.
This component?
The current dependent voltage source. It doesn't necessarily like take that electricity and then like modify it and then run it through. It just kind of maybe it just reads it in and then outputs something else.
Exactly, yeah.
Okay, so it's not like a contiguous thing. It's just like I'm looking at this and now I'm going to make this happen.
Yeah, I mean, basically, if you were to draw it like a block diagram, let me just, hold on, I gotta turn my brightness up. Alright, so if you were to draw it like a block diagram, it would be like, for that particular source, there would be some current in, and there would be some voltage out, right? That would be your current dependent voltage source. And then this block has some gain, G, which in that case was 2K. But inside of there, this node and this node are not necessarily connected to each other. They're just part of the same circuit, and we're taking this node as the input and this node as the output.
Okay, cool.
Yeah.
Is that how transformers work?
Transformers is like a voltage to voltage. You could call it a voltage dependent voltage source technically, but they only work for AC. So, actually, this is a funny story. I'm just going to tell everybody a funny story. So, transformers only work for AC signals, right? A transformer is basically a voltage to voltage converter that it might take in some really large voltage and step it down to some really small voltage, or it will take in a really small voltage and step it up to some really large voltage. And all of the principles like governing transformers is based on electromagnetism and how coils work. So, inductors basically, which is what we're going to talk about those in the second half of the class. But when I took EE220, which everyone here will probably have to take, how many of you guys are EEs? So yeah, you guys will all have to take 330. I took it over the summer, and we had a project where we had to design like an arc generator, like basically like a taser, using only household things. You couldn't. Yeah, I didn't know. I guess now that I'm looking back, like I could have like taken apart my microwave, but I wasn't about to do that. Like, give me a break. We just did this lame like little 9-volt battery and put like a little tiny spark gap, and like if you basically just short circuit it, it sparks. Like I didn't know what else to do. But some other guys in the class, there was like a group of guys who just loved cheating. Like they cheated their way through the whole degree. They were known for cheating on everything. They brought in like a shoebox, right? A shoebox, and there were just 2 prongs sticking out of it.
Oh my.
And they wouldn't let the professor look inside the box. And they had like literally wired like a button out so that when they pressed it, like it made this huge arc. And they like tried to explain the circuit and talked about how they used a 12-volt car battery, which is DC, and that they used a transformer from their microwave. And they got caught because you can't use DC to make a transformer. Like it doesn't work.
So what was in the box? What did they have?
They literally just bought a taser.
Yeah.
They just bought a taser and routed the little prongs out.
I mean, also, a freaking car battery in a box, that would break that box.
Yeah, I mean,
Batteries are heavy.
I know, but they thought that they could, like, you know. So just so you guys know, you can't use DC for a transformer. It doesn't work. It's using the alternating signals to generate. Basically, there's a ratio of the amount of voltage on on the input to the voltage on the output is the same as the ratio of the number of turns in the coil on the input to the number of turns in the coil on the output. Don't ask me how that works because I think that's like magic.
So how do you step up and down DC voltage then if you need to, if you can't use a transformer? What component would you use to do that?
So there's things called level shifters. There's regulators, voltage regulators that step down voltage. There's that op amp that I covered last time. You can set up an op amp so that it will step up the voltage, but there's no way to like necessarily, there's not a very easy way to like take in like say 2 volts and just boost it to like 100 volts DC, because typically what you need is 100 volts supply to get 100 volts out.
Yeah.
So when we have op amps, I think I talked about them last time, you have to power it with some voltage.
Mm-hmm.
And so say you power it with 10 volts. You can't boost the signal greater than 10 volts. But you could, so what you can take in is like you can take in 1 volt and boost it by a factor of 5 and then output 5 volts. But you can't output something greater than what you're using to power it. Does that make sense?
Yeah.
So DC, there's a bunch of different ways that you can step up and down voltage. But the reason why we use AC to transmit power is because we can use transformers, and transformers are so efficient. Yeah.
I was just going to say, it seems kind of redundant if you have like an op amp that can't output more than 10 volts, and you need to like move something from like 1 to 5. It's like, well, you have 10 volts very obviously, so just make that go smaller.
Right.
Instead of making something go bigger.
Well, typically it would be to like take in so for example, like my friend upstairs is working on a temperature sensor because, so our thesis was a leg sleeve that can sense the amount of pressure being applied by like a pressure wrap,
Right.
because diabetics, they need pressure wraps to like promote blood flow back to the heart. And you need to know how much pressure you're applying to the leg, because if you apply too much, you'll cut off the circulation, and then it's not doing anything. And if you don't apply enough pressure, then it's also not doing anything.
Right.
But the doctors wanted to also infuse temperature sensors into the device so that you can monitor skin infections. Those temperature sensors, when one change in a degree Celsius only outputs a difference of like 19 millivolts, right? Which is like ridiculously small. So if you want to be able to like see a bigger change, you might put that into an op amp with a gain of 100 or a gain of 1,000, and now you get 1.9 volts change for a change in 1 degree Celsius.
Right, but you would still need a source that can at least power that.
Right, so you would power the circuit with a battery, but nonetheless the sensor still has a really small output.
Okay, okay, I get that. That's pretty cool.
Yeah, so that's kind of the use. That's one use. I mean, there's plenty of uses. Did anybody else have questions about dependent sources? Like I saw a couple of hands. Yeah.
Back on the diagram.
This diagram or the homework?
The homework. I was at first I was like, wait, it branches off into 2 nodes at the bottom of like DC.
This?
So I was thinking of KCL, but then I realized it's referring to just DC or the current through DC.
Yeah, that's right.
So you don't do KCL at the bottom.
No, because no current will flow here because this is all 0 volts.
Okay.
So no current is gonna. There will be current flowing in this loop, and there will be current flowing in this loop, but ideally there wouldn't be any current like transferred between these 2 loops, because all the current that's being sourced from this source is going to sink through this resistor and stay in this path, and then over here the same thing's happening. I just drew a wire here to show that they were all connected to ground, but I think last class I deleted this wire and just grounded this separately and showed that it worked exactly the same.
Okay.
But that's only how it works in Spice again, right? Like in real life, you need to have the current going into your source.
In real life, you would have ground. All of your grounds would be connected anyway, so it would look like this. Yes.
So basically, whenever we're talking about current-dependent voltage source, can you just think of it as a battery that just fluctuates based on current?
Yeah, you could.
Okay.
You can think of it however you want, as long as you know that the current going through this wire right here is getting multiplied by 2,000, and then that's the voltage that I have coming out of here. That's all that. I don't care. However you want to think about it, because like I said, right, these things, like I think of them as amplifiers because there's 4 types of amplifiers: current to voltage, current to current, voltage to current, voltage to voltage. Like so it just makes sense to me to think of them this way. But most batteries aren't dependent on anything.
Right.
I mean, a battery's voltage changes as it drains. Like if you have a 4.2 volt battery, as it starts to drain, that voltage might drop to like 4.1, 4, 3.9, 3.8, and then eventually it's gonna die and it's gonna plummet. But I don't know of any batteries in real life where there's gonna be some current somewhere and the voltage of the battery is gonna output some voltage based on that current. Yeah.
I had a question on B.
B?
Yeah, I noticed how the first current is 1, but how is the second current 10? I thought you're supposed to multiply or add by 5.
Okay, so this is a voltage-dependent current source, right? So if I have 1 milliamp flowing in this loop, right, there's going to be 2 volts across this resistor, right? Well, that 2 volts is going into a current source, a controlled current source, basically, and being multiplied by 5 milli. So if I take 2 and multiply by 5 milli, I get 10 milli. What did you do? Or you don't have to say, but
I just I saw what was the LT system. Okay, they got to 10 milliamps somehow, and then I just did the basic math. I knew it was 10 milliamps, but I didn't know how we got to 10 milliamps.
Okay. Does that make sense? It's basically the voltage across this resistor is 2 volts, but we're just taking the 2, like we don't care about the units, and we multiply it by 5 milli, so we get 10 milli, right? Did any of the other ones cause problems for you?
No, the other ones.
Just that one? Okay. All right. Any other questions about dependent sources? Yes.
For 2B.
This one.
2D. Figure out how to get like VFD or VOD.
This V.
No, the VFD.
Oh, VFD.
Yeah, that's what. Yeah, I don't understand.
All right. So let me just. Do you want me to solve it?
Sure.
All right. Let me just draw it. I'll get a new piece of paper. So, what is this? 2D?
What happened to the students that were caught cheating? Did they just go the course?
No, they passed. They passed.
Why?
We had to split up into 2 classrooms, take a random number to see where our assigned seats were for the exam, because they didn't want them cheating on the final.
Right.
And then they all asked to go to the bathroom, and they let them all go to the bathroom
At the same time?
at the same time. They texted each other. It's just like, I mean, I don't know what. If as an instructor, what would you do at that point? Like, can you tell someone, no, you can't go to the bathroom? Like, I don't know if you're allowed to do that. Are you allowed to do that?
Theoretically, you could force them to
It's up to
stagger
them if
their
they wanna stay.
bathroom
You can
breaks.
tell them no. They have the choice to walk out, and even if you say no.
I guess that's true.
Gives them the liberty to leave, but if they leave, they forfeit their test.
I mean, I would have just failed them out of the class, considering the fact that they didn't know you couldn't use a transformer.
I mean, if you get caught.
Or the fact that they can give it to the car battery in the box.
Yeah, like, I would just
And
like
not
fail
let the
class because they don't
instructor
know
look
you
in the
can't put a
box.
car battery to a fucking shoebox.
Our instructor tried to look in the box, and they told him to sit down.
Whoa. Okay, I would have kicked him out of the class for that one.
I couldn't believe my eyes. All right.
Pass your class.
They passed the class, yeah. They got their degrees.
What are those people doing now? Do you have any idea?
Failing at life.
What the? I don't know what they're doing. That's a good question. All right. All right, so we had a question about this one, so let's do it real quick. So this is 5 volts, right? Are you cool with that? This first node is going to be 5 volts, right? And then this is 0 volts, right? So then the current flowing is going to be 5 volts minus 0 volts. I'll call this I1 divided by 15K, right? All right, so I've got my current, 0.33 milliamps. That's my current through VD, right? And now this is telling me to take that current and multiply it by 6, right? That's basically what this source is telling me. Take the current through VD. So I1 times 6 is equal to, let's call this I2. And that's going to be 2 milliamps, right? Any problems with that? All right, so now I've got 2 milliamps flowing through a 6K. So I know my drop there is going to be 12 volts, right? So that means VOD is going to be 12 volts, right? And then I have another 2 milliamps times 1K, or 2 volts dropped there. So then VFD would be 14 volts. Is that what you got in SPICE?
Yeah.
Yeah?
That's good. Figure it out.
Any questions like what about what I did? What was causing problems? All right, all right. Well, if you have more questions, you can let me know whenever. Any other questions? Anybody else have questions about this one, or anything else on dependent sources? All right. All right. So I guess back to this list. The next thing would be I'm going to start over from the top and just do KVL, KCL maybe. Is there anything in particular about KVL, KCL that caused problems, or do you want me to just like restate them and do examples? Just restate them and do examples? Okay. All right, so we got about 25 minutes, and then I'll give you guys the quiz. If everyone's comfortable with dependent sources, I think the quiz is going to be really easy. So let me just check this off, I guess.
Can you give us a hint on what dependent source would be?
I don't even remember. I just picked one of the homework questions, like changed it a little bit. I don't remember which one it was.
The best offense, no, like forgetting everything.
Huh?
5 seconds later, that's the best offense.
I think I did a voltage controlled something because I just didn't want you guys to have to deal with the 0 volt voltage. Let's see. All right, so KVL, KCL. All right, KCL, right? KCL states that. I'm going to state it. Maybe I'll state it a different way, and it'll be better for everybody. I'm going to re-explain it as if I've never explained it before. KCL states that the sum of all currents out of a junction is 0. And you're like, what the heck does that mean? All right, so let's say I have a junction. A junction is where multiple wires meet up. That's a junction. So I've got this junction right here. I'm going to call this I1. I'm going to call this I2. And I'm going to call this I3. All right? So what KCL states is that I1 plus I2 plus I3 is 0. Okay? It's similar to KVL, right? KVL states that the sum of all the voltage drops around a loop is 0, right? KCL is that the sum of all the currents out of a junction is 0. And that might look different from what I've explained in the past, right? What I explained in the past was if I have 2 currents coming in and 1 leaving, the 1 leaving is equal to the sum of the 2 coming in, right? That's how I've explained it in the past. It's the same rule, and I can derive it from there, but this is where it comes from. So let me do that now. So let's say I don't want to call that I3 going down. I want to call it I3 going up, right? I can just change the sign of I3. You guys agree? If I wanted to call this I3 now instead, I would say I1 plus I2 plus a negative I3 is equal to 0, right? Well, now I can just, move through here and do this, and then I can add I3 over to the other side. And that's what we've seen, right? That's pretty much what we've seen. If I have a current coming into a junction, the 2 currents leaving that junction are equal to the 1 current that came in, right? And this could be flipped around again to where if I have these 2 currents coming in and this 1 current leaving, I could say I3 is equal to I1 plus I2. But all of it's derived from this equation right here, that the sum of all of the currents leaving the node are 0. But if you start messing with the signs and flipping them, you get this case. I like this one the best, or even probably this one, where you have 1 current going in and then 2 separating. And the reason I like that one is because it relates heavily to the current divider, which we talked about, right? Because the current divider looks like this. So you have basically this junction, and you've got some current coming in, and you've got 2 currents leaving, right? That's the exact same thing that's happening here with my orange arrow coming in, and then these 2 leaving. That's the exact same case. So if you remembered, I called this I1, I2, and I total. So that would be I1 plus I2 equals I total, right? Any questions about this? I feel like everyone understands that right, if I take this I3 and I say it's going this direction, now I can just flip its sign. But I also feel like people still struggle with understanding negative, like what really is a negative current. And does everyone feel comfortable if I say a negative current is just the wrong way of defining the positive current? Like,
It's the opposite direction.
like if I say, again, like let's say I have 5 volts, and then I've got a resistor, and then I've got ground, and I have this 1K. We know that the current's 5 milliamps, right? It's flowing down. But if I were to tell you that the current was negative 5 milliamps flowing this way, does that bother anyone? I mean, it bothers me because it's wrong. But
Does that bother anyone? But if it doesn't bother you, that's wrong.
it bothers me, but if it doesn't bother you, that's cool. Like, I've always hated negative currents because it's just not right. But that doesn't mean that it won't work. Right? And here, let me show you why it works. Maybe this hasn't been clear up to this point. I have let's say I have 0 volts there and I have 5 volts here, right? And this is 1K. And so I know then that I have negative 5 milliamps flowing, right? I know that my drop is going plus to minus like this, right?
Yeah.
So I would say that my drop is negative 5 milliamps times 1K, right? Which is negative 5 volts. So if I'm dropping by negative 5, that means I'm actually going up by 5. So it works out. It's just a double negative for no reason, right?
Basically overcomplicates.
It basically overcomplicates things. But I want, because I think that when we were doing mesh, people were getting confused because, like, let's say I had my mesh loops. Let's say I've got like a loop up here. I don't know, something like this, where I've got some. I don't even know. I'll just draw something. I'm not going to solve this. I just want to show an example. So, like, let's say that I determine my currents this way. Let's say this was my I3 and this was my I1. All right? And let's say that I determined I1 to be negative 0.5 milliamps. And I determined I3 to be 2 milliamps. Right? If I3 is 2 milliamps, that means I know for a fact that 2 milliamps flowing in that direction is a component of this current flowing through that resistor. But I also know that negative 0.5 milliamps is a component flowing in that resistor as well. Because I think that I noticed from a lot of the people who came to my office, people were having a hard time once you get the currents finding the voltages in the circuit. Because maybe it was hard for you to determine what was, if I found I3 going in this direction and I1 going in this direction, then what is the total current flowing in this resistor and how do I know what direction it's flowing in? You basically want to reference it off of the positive current. Because you know, if I calculate I3 to be 2 milliamps, then you know that there's 2 milliamps. There is a component of it that's flowing in this direction at 2 milliamps, right? And then if I1 is negative 0.5 in the other direction, I could just redraw that as 0.5 in the same direction, right? So then the total current through that resistor would be 2.5 milliamps flowing in this direction. Is that clear? It may not be clear, but
I think you just need to think of it as solving it as algebraically rather than solving it as a component. That's the way I do it. At least.
well, you can do it algebraically, but it's very important to keep in mind the direction that it's flowing.
Yeah.
Because if you don't have it right, you're going to get the voltages wrong.
Yeah. Well, I'm talking about like when it comes to negative currents and stuff like that. Like when you're doing mesh theory, rather than like thinking like, well, that makes no sense because it's a negative current. Just solve it algebraically, then look at it and be like, oh, okay, it flows this way, yada yada yada.
Yeah, I mean, I don't think it necessarily makes no sense. When I say that this bothers me, it's just that once I see a negative 5 milliamps, I'd rather just look at it this way. I'd rather know that it's actually 5 milliamps flowing this way. But the whole point of me saying all of this is to say that it doesn't really matter because it's going to work out, and I've said that over and over in mesh, right? I just want people to make sure that it makes sense that negative 5 milliamps flowing up and 5 milliamps flowing down are equivalent. It's the same current. All right, what's up?
I have a question actually about that specific example. So if you had a current source, say like for the current of I3, and a current source read as like 2 milliamps. Is that necessarily true for the entire loop of I3 if you also have the what is it called, the current of I1 like supplementing it?
So the thing with mesh is that these currents are being defined as the current in a particular loop. So if I just got rid of these bottom two loops, right, that loop right there is I3. So you're saying if I had a current source here, right?
Right. Because I remember in our homework we had a triple loop problem with the current source, and I remember being freaked out because I was like, well, there's only 1 milliamp of current through the current source in that homework problem. But like if you look at the current through the resistors and stuff like that, it's obviously a lot more.
Right. So 2 milliamps is flowing in this loop.
Right.
That doesn't mean 2 milliamps is flowing in R16.
Right.
That means that this branch of the circuit that is only connected to itself, basically, it's like a self-contained loop until you get to R13, which is now shared between two loops.
Right.
Or R16, which is shared between two loops.
Right.
Right? So when you're going around this circuit, you know that 2 milliamps is flowing in here, it's flowing in here, it's flowing in here, and then when I get here, KCL takes over.
Right.
And now I have some of it going this way and some of it going this way. But the way that mesh works is that it basically, algebraically, it works out so that whatever loop currents I find, I can just solve for the currents through these resistors by taking them into account based on what loop they were connected to. So the current in this loop is 2 milliamps, technically. That doesn't mean that the current in R16 is 2 milliamps. That means that some portion of the current in R16 it's basically getting a contribution from that 2 milliamps
Right.
because it's in the same loop.
Okay. I think I had a hang up for mesh analysis where, because like remember you were saying mesh analysis gets easier when you have a current source because you can just be like I2 equals whatever the current source is labeled. And I'm
Right.
like, well, that's not true because the current in that loop is not just 2 milliamps.
Well, it is
Okay.
true, but let me tell you why it's true. Let me show you. So let me draw. I could probably just snip this and do it on a snipping tool. Hold on. Is it working? Something's not right. What in the world? Oh, it did a window. Okay, whatever. It's fine. All right. So basically, if I call this I don't know, I3. Is that fine?
Yeah.
I am right. I am right if I say that I3 equals 2 milliamps.
Right. But only for portions of I3.
No. I3 is 2 milliamps. It is 100% 2 milliamps. But the current that's flowing through this 5K is not I3. It's I3 plus or minus
The other.
I1.
Right.
Right? I3 is 100% 2 milliamps. It is.
Okay.
But I3 only flows there, 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 and there. And then when you get to other components, different currents are flowing through them.
Okay.
So let's say this is my I2, right? I am correct in saying I3 is 2 milliamps. I am not correct in saying that the current flowing through this 1K is 2 milliamps. Because in fact, it's whatever 2 milliamps minus I2 is. That would be the current that flows through this resistor. Does that make sense?
Yeah.
Yeah, what's up?
So, like, basically when you're doing the mesh analysis, technically and theoretically could, like, just draw 3 equivalent loops, solve all those 3 equivalent loops, put them back together, and then be able to do it in a way. So basically you're breaking it down into, like, equivalent loops in a way, similar to the way you do with, like, superposition or, like, combinational, like, of
I think so. I'm trying to think because you make a good point, right? Maybe it's just like superposition with
Yeah,
currents.
it's just like superposition, but you're just removing entire loops rather than just removing a source. Because that's I also had the same thing where I was confused because I'm like, well, it wouldn't just be 2 milliamps, right? And then I started to think about it that way, where it's like you're just removing entire loops and making them as equivalent circuits, and then solving the current in those circuits, then combining them back together.
So you're saying basically, what if I did a loop equation? I mean, yeah, we're basically redefining mesh, right?
Yeah.
But yeah, you're saying I could just take this 2 volt, the 1K, and the 2K, and solve it.
Yeah, solve it.
And then take the current source, the 5K and the 1K, and solve it.
Yeah.
And
take
then
those ones and solve it, or whatever.
I don't know. That's a good question. Maybe that would work.
I mean, it makes sense, but if you split your I2 around, you're going to be adding I3 and I2 with resistor 13
15, and you would just be subtracting your I1 and I3 at R16.
Is there a reason you?
Yeah,
chose
then
to-
you might be right.
Well, but there's also a loop that's just resistors. So it
Yeah,
wouldn't-
then you couldn't do anything with that
yeah,
loop.
It wouldn't have a current.
But if you had a
Yeah, I mean,
voltage,
but you, again, like,
well, then that might still work out, because what if that loop just isn't contributing anything?
Oh, I guess that's true. Yeah, it could just.
Like that, like in superposition, where sometimes you just get 0 volts somewhere. Like I think on this problem in particular, right? When you remove this, when you short across this, the contribution of superposition of VB3 is 0, and then the other case it's 2. So you get 2 plus 0, which gives you 2, and that makes sense because you know that this voltage is 2 volts, right? But yeah, I mean,
But I mean, you can also just.
it could work.
The reason I also thought of that is because throughout all of the theories we've had, there's been a voltage way to solve something and a current way to solve something. I see superposition as the voltage way to solve it by using the voltages and adding them all together.
And
to
mesh
solve
is the
that.
current way to
and
solve it?
mesh is the current way to solve it.
Yeah, I get
Which is
you.
kind of an interesting way to think about it. I don't know. Maybe
No,
I'm
it-
completely wrong on this.
No, I mean, it sounds like it might work. You could try it. I'm not going to try it, but you could try it.
No, that's not what.
So I know it doesn't matter which way you define your currents, but is there a reason you chose to define I2 going that way?
Oh no, that I would have never chosen to
'Cause
define
I
I2
would have
going this
chosen
way.
to define it the other way.
So would I. Yeah, I would. I always define it to come out of the battery like this because it. Then when I write my equation, I get plus 2 volts minus blah 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 blah. But yeah, no, I would always define it coming out of the battery. I would always define it the one with the current source in the same direction as the current source, so that then I can do this, right?
Uh-huh.
Aren't you guys glad I don't take my notes like this?
Yeah, you have really nice handwriting until you have to use the mouse.
This is horrible.
Everyone.
Doesn't Dr. Harris do this? But she writes. She uses a pen, yeah.
Yeah, she has a tablet.
Yeah, see. Yeah, I don't have any. All right, so any other questions about KCL? I haven't even done KVL yet, but KCL. Did everyone see how from this equation that I wrote, I can derive this? Everyone's cool with that?
Yeah.
All right. Now, what do we got? Like 7 more minutes. KVL, I'll do another review real quick, just maybe one quick one, and then I'll give you guys the quiz. All right. So again, I said KCL says that the sum of all the currents out of a junction is 0. KVL says that the sum of all voltage drops in a loop is 0, right? And that's just the definition of it. And so the example that I always take is just, we can start with just a simple voltage divider. The thing that's important to note about KVL is that it doesn't matter where ground is, right? Ground isn't even getting used. None of the voltages matter. What matters is the voltage drops. We're not even using any node voltages. So if I called this R1 and this R2 and this some voltage, right? When I go around this circuit and I'm trying to... Sorry. And I go around this circuit and I want to see my voltage drops. The voltage drop from this point to this point is V, right? I'm going up and I'm going up by V. So I write plus V. When I go across this resistor, my drop is whatever the current through it is times whatever the resistance is, right? And then the same thing with R2. It's whatever my current is times whatever my resistance is. So I end up making an equation. And so I can go ahead and go V minus I times R1 plus R2 is 0 if I group those. And I get that V is equal to I times R1 plus R2. Right? That's literally all it is. And mesh analysis is just multi-loop KVL. So that's literally, like, I think I covered KVL first and then I covered mesh, but maybe I didn't make it obvious that KVL is what we're using when we do mesh, right? When we do mesh, we're using KVL. But, if I have another loop here, if I were to have another loop here, now I have to take into account when I go across R1, I don't only have I flowing, I have I plus or minus whatever, the other loop is contributing. What's up?
So could one say it's spicy KVL?
You could say that. You could say that. What's up?
Well, with that one, since there's no other contribution, couldn't you just do those in parallel?
They're not in
You talking about these? Yeah, you could. You wouldn't have to use KVL here. I was just showing, like, if I added another resistor, right? Or if I added another loop, then that's where, this is a bad example, yeah. You would basically just combine those in parallel, and then you can just do one loop. But, like, for some of these mesh problems that we had, right, where we had, like, something like this. I don't know, something like this. And you have a current here and you have a current here. So when you go around this loop, you're doing the exact same thing I did here, right? You're going to go, okay, I go up by V, and then let's call this I1. And then when I get across this resistor, right, I drop by I1 times R1. That's my voltage drop across that resistor. But then when I get to this resistor, the drop is, I have two currents flowing through it, right? So I have to take into account both of those currents. I1 plus I2 is the actual current flowing through this resistor times, we'll call it R2, equals 0. And that gives me my first mesh equation, right? It's basically, yeah, I'm not going to call it what you called it. But that's basically what it is, right?
I will never be able to think about it the
Spicy
same way.
KVL, man.
I can't. You guys, man.
See, this is why you can never be a scientist, I think.
Well, hey, somebody decided to call it mesh. I don't know why.
I think if they called it spicy KVL, a lot more people would have understood it.
I think if they called it spicy KVL, somebody else would come up with another name. All right. Any questions about KVL? Any questions about this? Yeah.
If you have a negative voltage on your voltage source, you're not dropping the voltage, so you would start out with like negative V minus, and then.
So if you had like let's say negative 3 volts there or something, yeah. So when you go from this point to this point, you're dropping by 3 volts basically.
Right.
You're going down 3 volts. You could think of it as going up by minus 3 volts,
Right.
or I'm just going down.
But your equation would be minus 3 volts minus.
Right.
Okay.
Yeah, that's right.
Unless the battery was flipped.
Yeah, if the battery was flipped, then it would be minus 3, and then it would just be
Yeah.
positive. All right. Any other questions about KVL, KCL? I think that I'll check those off, and then we'll take the quiz. And then next time we'll go back to this list and see what else.
How many signatures do you need to get on your reading?
How many what?
How many signatures do you need to get after your reading?
I don't know. That's a good question. You guys.
Petition to rename it Spicy Cake.
You guys can call it whatever you want. If you get on an interview though, and someone asks you about spicy mesh, and you say spicy KVL, I don't think they're gonna know what you're talking about.
It's already got it.
Yeah.
Yeah, you're really watching your test.
Nope. You're not gonna give me the credit because I never called it that. There's gonna be no proof in these notes of me ever calling it that.
Well, in the video. Except the recording.
In the video, yeah.
Definitely had you say it.